Hello and welcome to today's USC Viterbi Live featuring Dr. Heather Culbertson. My name is Tiffany Tay and I am the Executive Director of Alumni Relations and Annual Giving here at the USC Viterbi School of Engineering. We started this Viterbi Live series about 3 months ago to bring timely, relevant research to our engineering community, and I hope you were able to join us for a few of these events. If not, they have all been recorded and are available on our online series library, which we'll post in the chat box for all of you to access. Today, we veer away from vaccines and PPEs and contact tracing to focus on something entirely different, touch. Or rather, haptics, which is the use of technology that stimulates the senses of touch and motion, which is the focus of Dr. Culbertson's team. Dr. Culbertson is a professor of computer science here at USC, and her research focuses on the design and control of haptic devices and rendering systems, human-robot interaction, and virtual reality. Particularly, she is interested in creating haptic interactions that are natural and realistically mimic the touch sensations experienced during interactions with the physical world. Previously, she was a research scientist in the Department of Mechanical Engineering at Stanford University, where she worked in the Collaborative Haptics and Robotics in Medicine lab. Please join me in welcoming to the Zoom stage, Dr. Heather Culbertson.
All right, thank you so much for the introduction. I am really excited to present today. So let me go ahead and jump in. Let me start sharing my screen so we can get to the slides. All right, so as Tiffany mentioned, I am a professor here in computer science. I also have a joint appointment in the Department of Aerospace and Mechanical Engineering. And here at USC, I direct the Haptics, Robotics, and Virtual Interaction Lab. And so today I'm going to be talking about how haptics can be used to help better our lives in a world where we are now socially distanced and are communicating almost exclusively online. So as you all know by now, the key importance of social distancing and really what social distancing entails. So as we started out with this pandemic in March, social distancing, meant staying home, staying away from just staying away from people completely. Now we're able to, go out, still staying away 6 feet from people. And the purpose of this social distancing is really to flatten the curve. So to flatten the curve of the cases of COVID-19, of the coronavirus, in order to not overload our medical systems, our hospitals, and to keep the the number of cases of the coronavirus to something that the hospitals and the medical system can handle. But what is not really talked about is the other curve, which is the mental health curve. Because I'm sure as you all experienced, our lives were completely turned upside down in March, where all of a sudden we're told we have to stay at home, we're not allowed to go out. This comes with, the inability to exercise, go to the gym, financial troubles for people who lost jobs, inability, food insecurity, because an inability, food insecurity, insecurity of essentials such as toilet paper in stores. So this causes this huge spike in ill mental health. And so really what I'm interested in is how we can use technology to kind of flatten this mental health curve to come to something that we can to better mental health, to better our mental health and make us, calm down and better have better interactions with people. So I'm not going to talk about how we can help financially or how we can help with food insecurity. What I'm going to be talking about today is how we can use technology to help with our social interactions, because humans are social creatures. We require the ability to interact with people. But when we started this pandemic, all of a sudden, you only have the ability to interact with people you live with, or virtually only have the ability, or virtually interact with the rest of your family or your friends. So I'm going to be talking about how we can use technology to increase these interactions and make them more natural. So what I want to talk about is not social distancing, but instead distant socializing. How we can socialize while still maintaining a distance from individuals. Okay, so we have seen a surge in the use of technology to socialize with our groups, our group of friends, our coworkers, our family, through such as Zoom, which enables me to give a talk to all of you, through video chat, talking on the phone, or text messages. And when this pandemic started, you would have these people put together all of these Zoom chats. And so not only are you using Zoom and video chatting, video messaging, you're using it to communicate for work. Now we're working from home, but you're also using it to have virtual happy hours, communicating with your friends, communicating with your families, cooking together. But that leads to what's called Zoom fatigue. Okay, so Zoom fatigue is a burnout that is caused from overuse of visual messaging or overuse of meeting face-to-face over video. And one of the key contributors to Zoom fatigue is that this kind of really close face-to-face conversations over video chat is not the normal way that we communicate. So it ends up being socially very exhausting, especially for people who are naturally introverts. Because naturally, if you were to have a conversation with a person, even in a face-to-face location, you are not, face-to-face, looking at each other, eye contact 100% of the time, 2 to 3 feet apart. And if you're not, facing down a firing squad of 20 people or 10 people in a Zoom chat for work, or, face-to-face for work, you're more spread out in a work scenario. So this amount of face-to-face communication is exhausting, because that's not the way we normally communicate. We don't normally have that stressor of looking people in the eye this much. That type of communication is normally seen as aggressive, but now we're doing it day after day after day, through work, through friends, through family. So what I want to talk, and we're not, through Zoom also, or through these video chats, we're not able to get the use of the full body language. We're seeing, torso up. And we're not able to use a large portion of, we're not able to get a large portion of what we normally use to communicate. Okay, we can't get body language. We can't use touch at all. So now that we are reopening up, we're able to see more opportunities for how we can safely socialize, but still there are limitations. So there's a great example of this bar that created these kind of bumper tables that maintained the social distancing. So now, even that we're still opening up, now that we're getting to open up, we're still having to maintain this 6 feet of social distancing. So some parks put together these social distancing areas. Bars are putting together these contraptions to allow social distancing. And when you meet face to face, they're telling, if anything, if you want any type of touch contact, maybe bump elbows, because that's maybe the safest type of touch contact that we can allow. But this leads to what is called touch starvation. Okay, so even though we're still able to socialize, and maybe even with the advent of all this video chatting and video messaging, we are able to communicate more, and we are in fact potentially socializing more. We are missing a key component, which leads to what's called touch starvation, or also known as affection deprivation. So, and that's the inability for any type of touch with people that are outside of your immediate environment. And you can see how much this affects people. So I love this example of these hug curtains that were really popularized and kind of went viral around Mother's Day. So people who did not live with their mother, did not live with their grandparents, and be like, I really want to go see them. I really want to give them a hug, but I really want to have that, that touch, that really natural interaction with them. But because of these social distancing rules, because they fall within that category of high risk, I don't want to have that face-to-face contact, because that could naturally, of course, have the transmission of the coronavirus. So people have been creating these hug curtains to allow for this very natural touch interaction. And to me, these hug curtains really show the innate need to have this touch, because we've really, over the past 3 months that we've been at home, that we have been social distancing, we've been missing this touch interaction. We really have been starved for touch, and starved for this physical affection. So what we have been doing in my research, even well before this pandemic started, is to look at haptics as a way to distantly socialize. So a way to use technology to allow us to communicate through touch over the internet, or through technology, through computers. So just a quick definition, a quick introduction to haptics for those of you who have never heard of it before. Haptics is just anything relating to the sense of touch, and it comes from the Greek word haptikos. So when we talk about haptics, we can mean anything relating to the study of the sense of touch, the study of the perception of the sense of touch, or going to technology that we can create. So where you probably have seen haptics before is the types of vibration that you have felt in your phone, or your watches, or your Fitbit, that provide notifications. So the type of haptics we're talking about is just an extension of that same type of touch information. So our sense of touch is so key to everything that we do. And so I truly believe that the sense of touch is our most key sense to how we interact with the world around us. And it's our most underappreciated sense. So we all know how much we interact with our world through sight, through sound, through taste, but you really don't stop to think how much you rely on your sense of touch. But without the sense of touch, you would not be able to walk, you wouldn't be able to move around, pick up objects. And it's a really fine sense as well that allows surgeons to be able to finely manipulate tools. allows us to use tools to build things, to put together things, allows us to discriminate the textures between cotton, between rayon, between velvet. And touch is also key in allowing us to communicate. And so that is what, so that's what I'm going to focus on right now. And this part is, how do we use touch to communicate, and how can we replicate this? So I hope I've shown to you why touch is so important and why it's important to try to find a way to replicate this virtually. But this idea of social touch, touch between individuals to communicate socially or to convey an idea, is a really challenging proposition. Okay, so social touch involves two people, and it involves bidirectional touch or bidirectional communication. It requires one person to initiate a touch and one person to receive a touch. So you have to have something that outputs or something that a person tries to convey, and then some kind of hardware that then plays that sensation to the person that is receiving the touch or who wants to feel the touch. Social touch is also incredibly complex. Okay, so we cannot just say that social touch is just a gesture. So we cannot say that social touch is just a handshake, or is just a hug, or is just a pat on the back. Because information is encoded in that social touch. Okay, so think of something simple like a hug. Okay, so a hug can mean a huge variety of different things depending on who is involved in the hug as well as the context. So a hug can be joyful, can be between friends, it can be loving between partners, and it can be consoling as well. So we can't just create something that gives a hug. We have to create something that gives a hug in a certain meaning and in a certain context. So this graphic here shows just some of the complexity behind social touch. Okay, so when you're trying to decode, what does a social touch mean? If someone touches you, gives you a pat on the back, gives you a hug, what you have to decode, what does that touch mean? What is that person trying to convey? Similar to how you try to convey what a person is truly trying to say verbally from not only the words, but also the tone of voice, who the person is that's trying to say it, as well as the context. So when we're talking about decoding the message behind social touch, we have to rely on the gender of the people, whether it's female, male, female, male, the age of the participants, the culture. So some cultures are going to be a lot more touchy than others. America tends to be a lot less of a touchy culture, but some Latin American cultures, French, Italian, tend to be a lot less touch averse. So they're going to be conveying a lot more through touch than some cultures such as American or British. You have to take into account the gesture, as well as the gesture that's used, whether it's a hug, a pat, a high five, a poke, as well as the context. What is happening? Was it in a conversation? What is happening around you? As well as the relationship. So it's been shown that individuals in a relationship, whether it's friends or romantic relationship, create a kind of touch language where it's much easier for them to decode what that person is trying to say, kind of their touch language or their love language. And then finally, the location of the touch is really important, because there are certain locations, of course, that are more aggressive than others, certain locations that are okay for social touch for people who are close friends, certain touch locations that are only okay for romantic partners, and certain locations such as only the hand or the shoulder that are okay that are only okay for people that maybe don't know each other quite as well. So the location of the touch is really important. So all of these factors have to be taken into account when you're trying to create a device that conveys a social touch or tries to convey emotion in a social touch. So this creates a really complex problem in a research standpoint. So our problem is that we want to create a device that person A has a device like a sensor, and they want to touch that sensor, and that sensor records what that person is, how that person is touching. Then that information is sent across the internet to person B. Then person B feels that touch either through, say, a touch text where there is no context, or in the context of a conversation such as a video chat like this. So our problem is, how do you convey that information? How do you sense that information? How do you convey it? And how do you create something in a wearable device that is easy, that is cheap, easy to wear, and is comfortable, and can easily convey all of that touch information? So all of these factors here that I'm talking about are really, really complex. So we are in the process of working more on this. We have a lot more work undergoing, which I can't talk about now, but I wanted to talk about some of our preliminary results on this, which is with a simple stroking gesture. So the reason we chose the stroking gesture is because it's limited to a single part on the body, and it can convey a wide range of emotions such as love, sympathy, and sadness. So the problem with creating a wearable haptic device that conveys something like a stroking motion is it's actually a very challenging mechanical problem. So it's a very challenging problem to create actuators or something that creates a stroking motion on the skin. Okay, so remember, we want to create something that is wearable, like an armband that someone can wear on their arm, and that they can move freely around. So we can't create this big, bulky mechanical thing that actually, takes a finger and strokes it back and forth, because that's going to be this big, bulky, heavy mechanical thing. So instead, we needed to think about what types of actuators are available haptically. So we don't want to use vibration for these social touch. We don't want to use just vibration for these social touch interactions, because vibration can be distracting and can be annoying for when it's used repeatedly. So it's great for alerts, but if you're going to use it repeatedly, it can be distracting, which is, of course, not what we want. We want something that feels very natural, and there's not that type of sensation naturally in social touch. So to create this sensation, we did something called haptic sketching, which is very, very low level. Let's not play around with electronics. Let's just play around with everything we have in lab, and try to hand actuate on the arm to create this type of sensation. So what we ended up with after trying a lot of different things. I mean, we tried slinkies, we tried wood cutouts, we tried scalp massagers, we tried a whole bunch of different things. But what we found actually feels the best, or felt the best, was an array of magnets. So you have this array of magnets on the skin, and they're all oriented the same way. So they're all oriented, say, with the North Pole facing downward. Then you take another magnet and you hover across, and as you move it across the top, then it pushes all the magnets down in a sequential motion. And that's the same type of, say, pressure profile you get as taking my finger and pressing into the arm and then slowly moving it down the arm. So once we created it with this really, really low fidelity, low technology prototype with literally magnets Velcro to my arm, then we needed to come up with a way to how to actuate this electromechanically. So to do this, we used voice coil actuators. So these actuators are speakers. We actually buy them from an audio company, and they're speakers without the coils. So you send a current signal through them, and you get a little bit of motion up and down. So we needed actuators that have a relatively high force, can be driven at very low frequencies. We're talking about very low motion, and have a reasonable depth of motion. So we take these actuators, we put them in an array. So we have a linear array of 6 actuators, and we actuate them sequentially. Okay, so we actuate them to just move up and down. And we have an array of 6 of them. So what we do is we have a delay between the actuators. So you have one start to go down, and then for this one starts to go down, then this one starts to go down. Then we looked at what is the delay between the actuators that creates a smooth sensation. So as you can see by the plot here, if you have if you look at the heat maps on the bottom here, if you have a short delay, then that creates a very smooth sensation. And if you have a very long delay, then it feels like just individual pokes. So in doing this way and in testing with a human subject and testing with human subjects, then we were able to tune it and creating something that feels like a very pleasant stroking sensation. So this video here, since you can't feel it, this video here shows you what the actuation looks like. And so as you can see here, you can probably imagine what the pressure profile then looks like on the skin. So you can imagine like a wave moving down the skin. And so this is how we create that stroking sensation. Then we put all the actuators in a wearable device and create this very smooth stroking sensation. So now we're looking at expanding this similar type of hardware and creating a lot of different gestures and a lot of different contexts, which unfortunately I'm not able to talk about right now, but if you're interested, please keep on the lookout for this work coming soon. So now I've talked about how we can use this to communicate. So you at home would have this device, another person would have a sensor. They would touch the sensor, say, I want to, do a pat, I want to do a stroke. Then this type of device would actuate. Another type of touch we are looking at in our lab to reduce this sense of isolation is robot social touch. So we're not thinking about robots specifically designed for touch. Okay, so we're not looking at robots in the home that are specifically designed to be companions. What we're thinking about is, given that robots are being designed to be in the home, to be cleaners, such as the future, what the Jetsons envisioned with Rosie the robot, is if people have a helper robot in the home, do they want this robot to communicate with, do they want this robot to socially communicate with them? So do they want the robot to be able to talk, to have social touch interactions with them, similar to what we talked about with human-human interactions, or do they only want the robot to do basically mechanical tasks, such as cleaning the apartment? So we did a very simple test where we had a Sawyer robot, which is basically a very large, which is a robotic arm with an iPad on a stick. And we looked at the simple gesture of patting. So patting on your forearm and patting on your shoulder, to test whether people liked this interaction and whether people were interested in interacting with the robot this way. So one thing interesting we found is that first, when we gave people the robot, or set people in front of the robot and said, okay, the robot's going to touch you, the robot's going to pat your arm, people were really, really hesitant of this interaction. And it's because the Sawyer robot is actually quite this large robot, and it's very safe. It's designed for interactions with humans, but it can be very large, very intimidating. So what we decided to do is actually have a fun interaction with the Sawyer robot, like a high five interaction. Just tell the people, okay, we're gonna come in, you're gonna high five the robot a couple times. Like, this will be fun. You can see the robot is actually really, really safe. And then people became really excited to interact with the robot. People wanted to interact with the robot then after that. And we found that people liked interacting with the robot. So, and we were actually able to convey many different emotions with the robot, even though we weren't trying to. So we changed how fast the robot was moving with the pat, how hard the robot was moving with the pat, and whether the robot would just go down and back up, or go down, pause a little bit, and come back up. And we found that people attributed emotions to the touch, even though we weren't actively conveying emotion. And so this research really gives us a good indication that people are interested in interacting with robots socially. And so we're going to keep moving forward in this direction as well, and looking at different interactions we can have and different emotions we can have robots display. So in the couple minutes I have left, I am going to switch gears a little bit out from social touch and talk about how we can use a completely different type of haptics to help us still reduce isolation, but in a completely different way. So what I'm going to be talking about is data-driven haptics for essentially feeling the internet. So there's been a big push now for people, on tourism boards, for having people virtually visit museums, or virtually visit areas, and people are you're able to virtually ride a roller coaster, virtually visit Jamaica, but you can't touch any of the things that you were able to virtually visit. So we've been doing work in data-driven haptics that can actually record these objects that are virtual objects in museums, objects that are across the world, which then you would be able to feel in your home without going anywhere. And so this type of kind of recording the feel of objects is called haptography, or haptic photography. So in the same way that photography, visual photography with a camera takes an interesting visual snapshot of an image that you want to then look at or recreate later, haptography takes an interesting touch snapshot of something that you want to feel later, whether it's an interesting object, an interesting touch interaction. And so the way we do this is we have a device that's we call a haptic camera. And so this haptic recording device has sensors in it that are similar to the sensors that we have in our skin that allow us to feel mechanical signals. So touch is a mechanical process. It is a, so touch is a mechanical process, and it creates mechanical signals such as forces and vibrations that we feel, that are sensed in our what are called mechanoreceptors, that then go to our brain and tell us, yes, this object feels like this. This object is rough or smooth or slippery. And so what we do with the haptic camera is we have a force sensor, we have accelerometers, we have position sensor. We're now working with the sound of objects to record what objects sounds like when you scratch objects and it gets that, and you can tell like it's rough when you just scratch it. So we have this recording device, we move it across the surface, and we record the vibrations and we record the forces and speeds at which we move. Okay, so when we're recording like this data, we're recording not just how the object feels, but it's how the object feels based on how you move. Okay, so we get data that looks like this, and we can see that the middle plot is speed and the bottom plot is force. So we're interested here in the acceleration or the vibration that's in the pen. We can tell that the vibration changes a lot if I move faster, if I move slower, if I press harder, or I press softer. So our job here is to model this vibration as a function of how I move. So I'm not going to go a lot into the math here. I'm happy to chat more about it in the Q&A if you're interested. But basically, we create a model of that vibration signal, that texture. Says this texture feels like this if the person moves with this force and speed. We create this model. So this plot of all these triangles here, this is our model that says this is how the surface feels. This is how this vase feels. This is how this piece of marble feels. This is how this fabric feels. Then using this model, we can create virtual sensations. Okay, so I can create virtual sensations that now if you touch a virtual version of that piece of fabric or that piece of, or that vase, I can make you feel then that virtual object that makes you feel exactly like the real object, even though you're touching something that's really not there. So we can do this in multiple different ways. One of the most common ways is on a tablet computer. Okay, so we see here we have a piece of virtual canvas. So it feels very bumpy. And what we have here is we just need to sense how the person's moving. And we have this little actuator here. It's also a voice coil actuator. So similar to what we used in the social touch device, but we're moving it a lot faster. So instead of moving like very low motion, we're moving it really, really, really fast. And we're outputting vibration instead of motion. So you use this device, you scratch across this piece of virtual canvas, and the pen vibrates, and it makes you feel as though you're touching that real piece of canvas. So we can do this with pieces in a museum. Okay, so this here is a picture of a piece of piece of dinosaur skin at a museum in Houston that I took. So we could, record how this piece of dinosaur skin feels, and then at home across the world in classrooms, we could have students feel what this dinosaur skin feels like because they're not able to get out to these museums, can't actually go around and feel these things. So not only can we do all these really small pieces, but we have the opportunity to do three-dimensional recreations as well. So, and we have completely non-destructive testing. So we can actually let you feel things behind the glass as well. So very delicate vases, or even the full dinosaur skeleton that we could shrink down and bring into your classroom. And so this is an opportunity for us to use haptics to let you just get out there and visit things that you can't do right now because of social distancing and travel restrictions. So I want to wrap up my talk here, and I want to thank all my students, of course, who have been working on it. So I have a much larger lab. This is just a subset of my lab, and of course, for the past couple months, we've been meeting through Zoom. So I'm looking forward to the day I'll be able to meet with them in person. But for now, this is our virtual lab picture. And so I'll stop here and be happy to take any questions that you have.
Thank you so much, Dr. Culbertson. That was absolutely fascinating and really validates why I feel so much more tired after a full day of Zooms.
Yes.
That now makes complete sense. So we do have a question from the audience from Gerald. What are the mechanical properties of the probe for recording textures, and are they similar to a human fingertip?
Very good question. Very good question. So the probe that we're doing to record texture, we are actually, right now we're doing textures as felt through a tool. So textures, as felt through a pen. So when you have a pen and you touch objects through a tool, and you get this rigid link, and that's what creates the vibration. So we're able to simplify the mechanics down to, okay, I only have a single point of contact, so I'm able to just recreate those vibrations. And so this is very different from what you feel with the bare finger. So bare finger, you still feel the vibrations, but a lot more what you feel is the deformation, the individual deformation of your skin. And so being able to replicate the individual, the deformation of your skin at a fine enough scale as what you can actually sense is a really, really challenging problem. And so that is something that we are actually working on in our lab, and is something that is very much in active research in haptics.
Got it. And do you have a general timeline for that? You don't have to say.
we don't. So people have created very small, maybe inch by inch. But the problem is that you create an area that's, 1 or 2 inches square, and then you have this like massive, 2-3 foot wide area for the actuation. Right. So we can create something that's very small, but it's not portable.
Got it. All right, we have another question from Carla. Can you see a path to the ability to move the vibration cylinder onto a finger to rub with a fingertip and sense?
Yes, so there has been work. We can make these vibration actuators much smaller. I know there's been a lot of work. So the voice coil actuators are just one type of outputting vibration. There's been a lot of work in material science as well for doing it with different types of materials and piezos. Something that we can do a much smaller. For putting something like this on the fingertip would be you can do, but it restricts your motion. But there are other actuators out there that could feasibly do this.
Got it. Thank you. So a comment and a question from Kevin. Comment was, great talk. Question was, when capturing texture surfaces, how does the pen compare to imaging-based methods?
Great idea. Okay, so this comes down to the benefit of data-driven methods. Okay, so image-based, we are able to get a really good image of the texture of the surface. But the problem is that when you try to render that haptically, you have to do collision detection. So if I have So I have to have a physics-based model that says the system is going to produce a vibration like this if it hits all the, if I collide with this bump that I see in the surface. So first of all, creating that physics-based model that creates a vibration that is realistic is challenging. Secondly, in order to do that collision detection to tell when does my pen hit a bump is really challenging to do. The benefits of doing this data-driven modeling is that it's not position-based, so I don't have to do collision detection at all. So in that picture here, you can see all the little bumps on the canvas. I don't tell it all. People say like, oh, I can feel the bumps on the canvas, but we don't model the bumps at all. So I don't model each individual bump, so I don't have to tell when you've hit anything on the image. It's just based on how fast you're moving, and so it's a lot quicker for us to render because it's actually based on real data. So we're modeling the output rather than creating a physics-based model to predict the output.
Oh, wow, that is really fascinating. Okay, another question coming in from Carla. Have you considered the ability to put a heating spot on a computer or iPhone to roughly simulate a finger touch from a distance or a kiss from a distance?
That is a very interesting idea. Yes, temperature is huge in touch. Temperature is really, really big in touch. So they have done, I'm sorry, I'm blanking on the name of the authors right now, but there is a study out there that did, it's work out there that did a study on a warm robot, an artificially warmed robot, and a cold robot, and found which one was more inviting for interactions. And definitely, when you're having social touch, you want to invite touch, especially in a social manner. You do want temperature. You do want things to be warm. And so I didn't present it here, but we have done some work where we did some thermal actuators where we had hot and cold water cycled through actuators so that we were able to display temperature that way. So we've done it with water, so fluid at different temperatures. And the traditional way to do thermal displays in haptics is with Peltier devices. And so Peltier devices, it's layers of ceramic, you apply a voltage, and then it's a heat pump. So one side gets hot and one side gets cold.
Got it. And we actually just had another question come in that was directly related to that, to the recording, transmitting, and rendering of that temperature sensing data. So thank you so much for covering two questions in one. Okay. We have another question coming in from Jules. Was there any kind of material or shape between the voice coil array and the wearable design that would interface with the skin? Or are the voice coils just directly moving to the wearable?
So the voice coils, there was actually a lot of work in order to get things to, in order to lay perfectly. So the voice coils are not rigidly attached to anything. So we tried things, putting them on a rigid plate and then have the rigid plate on the arm, but people have very differently shaped arms. So everything is very flexible. It's just directly attached to it's directly attached to fabric. So it allows it to naturally conform to the user's arm. One thing we did have to do is to make sure that the fabric on top of the voice coils was inelastic, so that, because if you have elastic fabric on top, then the actuators actually go up rather than down. So we have like a stiffer fabric on top, but still allows them to naturally conform to whatever user's arm we put them on. And then the Velcro allows us to individually adjust it.
Fantastic. Thank you so much. And I think the last question is, for those of us that don't have access to any of these haptics therapeutics, and we're still quarantining at home, what are some immediate recommendations that you have?
So immediate recommendations is to try to have some type of touch. So there's, I mean, in a typical world, common recommendations for touch starvation are to, get a manicure or to get a haircut. So even if you're living alone and are not able to get this actual personal interaction, everyone knows how good it feels to go out and get your hair washed by someone else. So of course, I recommend just being able to have these touch interactions, of course, on a very as safe as you can have them, but it's just as much as possible, because I don't think you realize how important these touch interactions are until they're gone. And I don't think we've realized how much we actually miss them.
That was a fantastic answer. Thank you so much, Dr. Culbertson. And that brings us to the end of this webinar. Thank you all for joining us, and special thanks to Dr. Heather Culbertson for spending time with us today and giving us this presentation. Today's webinar was recorded and will be available on our online series events page in about 24 hours. Please join us again tomorrow as we feature how math can improve cancer treatment, featuring Dr. Stacy Finley. We look forward to seeing you there. Thank you everyone again, and fight on.
Thank you.
Thank you.